Welcome everyone. In this video lecture, we will discuss about direct sum of subspaces. Before going to the definition of direct sum, let us understand how to define sum of subspaces. Sum of subspaces. So let we have W1, W2 and Wk be some subspaces of a vector space V. We define the sum of these subspaces as the set the sum of these subspaces is defined as the set having the elements of the type v1 plus v2 plus vk, where each vi is the member of wi, and we have this condition for all I varies from 1 to k. So this type of the set, which is obtained by adding the members of or the elements of each subspaces, is called direct sum of subspaces, and it is denoted by W1 plus W2 and Wk, or you can also use the notation summation wi, I varies from 1 to k. So this is equal to this set. You can check that the set that we obtain by adding the members of these subspaces, this set is itself a subspace of the vector space. You can check this. You can verify this. Let's take one example of the direct sum of subspaces. Let we have a vector space R3, which is a vector space, and let W1 is one of the subspace of this R cube, which is nothing but xy plane. And we have another subspace of this vector space, which is say yz plane. So you have the xy plane where the third coordinate will be 0 always, and we have yz plane where the first coordinate will be 0 always, because it's a yz plane. X coordinate will be 0. So we claim that this R cube is equivalent to, is obtained by W1 plus W2. It is the sum of these two subspaces, because we say that R cube is obtained by adding the members of W1 and W2, because if you take any element, any vector of R cube, अगर आपने कोई वेक्टर लिया R cube का, then you can write ABC as A00 plus 0BC. This is the vector which belongs to W1, right? And this is the vector which belongs to W2. This vector belongs to W1, this vector belongs to W2. So you can write any member of R cube in this way. You can represent each and every member of R cube by this representation. Means you will always have elements of W1 and W2 both sides. Okay, so in this way we say that this R cube is sum of W1 and W2. But आपको ये लग रहा होगा कि मैंने A00 लिखा है, I also can write this as हम ABC को ऐसे भी तो लिख सकते हैं, AB0, which is the member of W1, because W1 denotes the XY plane. This vector is in XY plane, and we can take 0, 0, C. This belongs to W2, which is of YZ plane. Okay. So this vector is the member of W1 and this vector is a member of W2. This representation of this vector that we obtained by these two vectors is different from what we have obtained here, right? So this representation of this vector ABC is not unique. Okay, representation of vector, you can write here ABC, which belongs to R cube, is not unique. Unique representation नहीं है. So we should have some condition to have the unique representation of the vector ABC that generates the definition of direct sum of subspaces. So we define now direct sum of subspaces. Direct sum of subspaces. क्योंकि इस वेक्टर की रिप्रेजेंटेशन यूनिक नहीं है, आपने देखा ही कि आप ABC को दो तरह से लिख रहे हो, राइट? तो यूनिक रिप्रेजेंटेशन के लिए हमें कुछ और कंडीशन ऐड करनी पड़ेगी सम ऑफ सबस्पेसेस की डेफिनेशन में. तो जब हम एक्स्ट्रा कंडीशन उसमें ऐड करेंगे तो हम उसे एक नया नाम दे रहे हैं, which is called direct sum of subspaces. Okay, so again we have some collection of subspaces W1, W2, WK being subspaces of a vector space V. Okay, so V is called direct sum of these subspaces Yeah, you can write direct sum of W1, W2, Wk, and uh, let W1 be subspaces of vector space V, then V is called direct sum of these subspaces if V is obtained by adding V is nothing but sum of Wi's, and we have defined the meaning of summation of Wi's. It is nothing but W1 plus W2 plus Wk. As usual, this condition was same. Okay, this condition is same. With this condition, we have another condition that Wi, Wj intersection summation Wi, I is not equal to j is equal to 0 vector. Okay, means there's not any vector common between these two subspaces. One is the subspace which is the sum of uh, the members of the elements of subspaces, and this is a particular subspace. So this type of addition of subspaces is called direct sum of subspaces, and this is denoted by W1 plus. A special type of plus is used here. Okay, this is the notation of direct sum, the plus sign within a circle. Okay, so we have one condition which is same as in the definition of sum of subspaces, and the second condition is this. For example, if we have a vector space V which is equal to R4, okay, where we have this vector space, and suppose we have W1 which is subspace of this vector space having the vector of the type AB 0 0, where A and B are real numbers, and another subspace which is W2 which is having the vectors of the type 0 0 C 0, where C is a real number, and we have another subspace which is denoted by W3 which is 0 0 0 D, and D is a real number. Okay, these are three subspaces. Then you can see that for any vector A, B, C, D that we obtained from this vector space or R4, we can write this A, B, C, D as A, B, 0, 0, 0, 0, C, 0, and 0, 0, 0, T. इस तरह से आप लिख सकते हैं इस वेक्टर. This belongs to W1, this belongs to W2, this vector belongs to W3. So clearly V is sum of Wi's. Okay. This condition was the first condition, this one. We have to check the second condition. In second condition W1, इसका इंटरसेक्शन आप लेंगे बाकी दो वेक्टर स्पेसेस के सम से. तो जब आप इन दोनों सब स्पेसेस का सम करेंगे तो उसमें किस टाइप के एलिमेंट्स आएंगे, किस टाइप के वेक्टर्स होंगे जिनका फर्स्ट और सेकंड वेक्टर 0 होगा. ओके, इसमें इस टाइप के एलिमेंट्स होंगे, सॉरी 0 0 C D टाइप के. और यहाँ पर किस टाइप के एलिमेंट्स हैं, किस टाइप के वेक्टर्स हैं, इसमें फर्स्ट और सेकंड नॉन जीरो एंट्रीज हैं एंड थर्ड फोर्थ मेंबर्स आर 0. A B 0 0 इस टाइप के मेंबर्स हैं. सो देयर इज नो वेक्टर कॉमन in these two sets except a 0 vector. So intersection of these two is a 0 vector. Okay, it is a 0 vector. Similarly, we take W2 and we take the intersection of W2 with W1 and W3 sum. इन दोनों के सम से हम इस सब स्पेस का इंटरसेक्शन लेंगे, मींस इस सेट का इंटरसेक्शन इस सेट से लेंगे, तो कोई भी एलिमेंट हमें कॉमन नहीं मिलेगा एक्सेप्ट अ 0 वेक्टर. We'll check this for W3 also. So this is a 0 vector again. So all the two conditions, the first one was that vector space should be the sum of subspaces, and second condition was this. Both conditions are satisfied. So the given vector space R4 is the direct sum of these three subspaces. So we can write that V or R4 is, or you can write equal to W1 plus W2 W3. ये सारे कैपिटल्स लेटर हैं क्योंकि ये सेट हैं. अगर इनके एलिमेंट्स हम लेंगे तो स्मॉल लेटर से हम डिनोट करेंगे. ओके, so this is the concept of sum of subspaces and direct sum of subspaces. The difference between two, try to understand the difference. In one case we have only the addition of the members of subspaces, and in second case we have this extra condition which you can say due to which we have uniformity in the representations of the members of the vector space. So this is called direct sum of subspaces, and the previous one was called sum of subspaces. So I hope you understand these two concepts. If you like my lecture, press the like button and share my video about this direct sum of subspaces. And you can also subscribe my channel to get the notification of any other new video on this topic. Thank you very much.